Good afternoon, class. So I'm Mr. Byron, and today I'll be taking you through organic chemistry, which is a preliminary topic for organic chemistry in high school. So organic chemistry is the third topic in Form 3 chemistry syllabus, and today we shall be talking in details what it entails. So, like I said, today the topic is organic chemistry 1. Organic chemistry 1, and it's a preliminary topic, like it's the introduction topic for organic chemistry, because organic chemistry is also taught in Form 4 in details. So today we shall be talking about what organic chemistry 1 entails. To begin with, we shall give the definition of organic chemistry so that you can all get the overview meaning of what organic chemistry is. So organic chemistry, it is simply the study, from definition, to the study of properties, structure, composition, and reactions of organic compounds. Good. So from definition, organic chemistry is simply just the study of properties, structure, composition, and the reaction of organic compounds. We are interested to know what are the properties and what's the structure and the composition and how does these organic compounds react. Now, when we talk about organic compounds, it is simply just a group of chemicals. You have many chemicals, but now specifically organic compounds are now a group of chemicals that contain carbon. So when we talk about organic compounds, we are simply talking about that group of chemicals that contain carbon. And among that group, we have a group that contains carbon, which we call hydrocarbons. So our topic today will major on hydrocarbons, which is a group of organic compounds. So let me just write here hydrocarbons. We want to see what hydrocarbons are. So like I've said just a second before, organic compounds, that just those group of chemicals that contain carbon. And one of that groups is hydrocarbon, which comprises of carbon and hydrogen. So hydrocarbons are simply group of organic compounds. They are a group of organic compounds containing carbon and hydrogen only. So at one point, you will be asked to define what's a hydrocarbon. And just remember that hydrocarbons, when you talk about hydrocarbons, they are specifically those groups of compounds, organic compounds that contain carbon and hydrogen only. And today we are going to major on the 3 groups of hydrocarbons, which are the main subtopics in this main topic of organic chemistry. And those are alkanes, alkenes, and alkynes. Good. So, as we are going to study, under these 3 major subtopics, we are going to study the properties of these groups of hydrocarbons, their structures, their composition, and how they react with other elements like the halogens and halides. So that's what we're going to study under these 3 major subgroups of hydrocarbons. So just to save on time, we are going to begin with the alkanes. Alkanes. Now, we want to see how are these hydrocarbons classified. Why are there alkanes and why are there alkenes and alkynes? So, beginning with alkanes, when we talk about alkanes, they are specifically those groups of hydrocarbons whose carbon, that carbon is linked to another carbon. It's covalently bonded to another carbon with a single bond. This is what I mean. Alkanes, the carbon bond is covalently bonded to another carbon with a single bond. That's why they lie under alkanes. So we shall see that we shall be talking about properties of carbon in alkanes, and we shall see that alkanes are referred to as saturated. They're saturated compounds. And the reason why we call them saturated compounds is because this single bond, they have a single bond, and that single bond cannot be further broken into any other bond in order to accommodate any monovalent or even divalent atom. like that's the maximum number in which it can be subdivided. So they cannot be subdivided further from that. Good. Let's proceed. So from definition, I said alkanes, they are group So alkanes are a group of hydrocarbons in which the carbon atom is bonded a group of hydrocarbons in which the carbon atom is covalently bonded to another carbon by a single bond. Good. So all hydrocarbons in which a carbon atom is bonded to another carbon atom with a single bond will always lie under alkanes. And these alkanes, they always have a general formula in which is CnH2n plus 2. Yeah. Good. Like you're saying, this is the general formula of the alkanes that classifies them under the homologous series. So all the alkanes under that homologous series, they follow this formula. So when we talk about homologous series, we are simply talking about those compounds which belong to the same group that have the same structural formula. And this is the structural formula of the alkanes. They all have this general formula, CnH2n plus 2. So if you want to come up with a name of alkane or the formula of alkane, then you need to follow this formula because this is the general formula of alkanes. Yeah. So said that homologous series, they are groups of compounds that have the same structural formula. So, and the structural formula for alkanes is CnH2n plus 2, where C stands for the number of carbon, this N stands for the number of carbon, and 2n plus 2, it represents the number of hydrogen atoms in that bond. Just for example, if we have one carbon atom, then the formula will be C, because N is 1, because we have one carbon now, N is 1, so hydrogen will be 2 times 1, which is 2, plus 2, giving us 4. So if we have one carbon, this will come to be our formula. If we have two carbon atoms, then we shall have 2 carbon atoms, because N will be 2. So hydrogen will be 2n plus 2, which will be, okay, let's proceed. So let's talk about the characteristics of this homologous series. While talking about the characteristics of homologous series, the characteristics number 1, because we said homologous series is simply a group of compounds that contain the same structural formula. So while talking about alkanes, they lie under the same homologous series because all those compounds that lie under alkanes, they have this general formula, which we call the same structural formula. So property number 1 of homologous series is that they all have same structural formula. They all have the same structural formula. They can be represented by the same structural formula, which is CnH2n plus 2, and those are specifically the hydrocarbons on the group of alkanes, on that homologous series of alkanes. Good. Another second property is that those compounds which belong to the same homologous series, you will realize that they have the same physical and chemical properties. So they have same physical and chemical properties. As we shall be seeing in our next subtopic, that the properties of alkane will always be similar down the group, from the alkanes to the alkynes. Good. That's good. Property number 3, which is the property of those groups that belong, or those compounds that belong to the same homologous series, and that one, these ones. The first one, you have said that they all have same structural formula, and like we have seen here in these examples of alkanes, which we said they belong to the same homologous series, you will realize that all alkanes in this group can be represented by the formula, which is the structural formula CnH2n plus 2. Also, we said that they have same physical and chemical properties. All hydrocarbon will exhibit same physical and chemical properties, that including their physical color, physical appearance, smell, and also how they react with other elements. That's good. Also, all compounds that belong to the same homologous series, they differ with the one adjacent to them with atomic mass of 14. So we have this unit, which you call it unit CH2. So you'll realize that a hydrocarbon, if they belong to the same homologous series, then the adjacent one will differ with the other one with only atomic mass of 14. And the atomic mass of 14 comes from this unit CH2, where carbon gives us 12 and we have 2 hydrogen giving us 14. For example, we just represented here a hydrocarbon with 1 carbon and 2 carbon belonging to the same homologous series of alkanes. So if we find out the atomic mass, the atomic molecular mass of this carbon, or this hydrocarbon with 1 carbon, it will be 12 plus 4, giving us 16, while this one will be 12 times 2, which is 24, plus 4, giving us 28. So you will realize that they're different. This one is 24 plus 4, that gives us 28. So you realize that the difference will be giving us 28. Yeah, here it was 2 carbon atoms, Cn, that is 2, then H2n, that's 2 times 2, which is 4, plus 2, that will give us 6. So, yeah, I'm sorry for that. So you will realize that the atomic mass in this first hydrocarbon with 1 carbon will be 12 plus 4 hydrogens, which is 16. And here, the relative atomic mass of carbon is 12, and we have 2 atoms of carbon, so that will give us 24, plus 6, giving us 30. When you take 30 from 16, you realize that because this one is adjacent to this one, the difference of the relative atomic mass is always 14. So that's one of the properties of those compounds which belong to the same homologous series. Good. Good. So most chemicals or most compounds in chemistry, they are obtained by at least 2 methods. One is the industrial method, and then 2, we have the laboratory method of preparing them. So talking about alkanes, let's see their main source or their chief source, which is the industrial source, and then we shall later look about or talk about their laboratory preparation. How can we obtain them in the laboratory, or how can we prepare them in the laboratory? So first, let's talk about how they are obtained at industrial level. Now, alkanes, they occur, you can obtain them from, we have a crude oil deposit, we have crude oil, we also have natural gas, and we have a biogas. So biogas can be prepared manually at homesteads, and crude oil is extracted, like it's found as a raw mineral or raw material underneath the ground. So in crude oil, if we carry out fractional distillation of crude oil, we shall obtain alkanes. Also, natural gas, and natural gas is simply just a top layer which is found in a crude oil deposit. So everywhere there's a crude oil deposit, there's always a top layer comprising of the natural gas. And this natural gas, it always comprises of alkanes. Now, from the crude oil and the natural gas and the biogas, we can obtain alkanes in large quantities, that is at industrial level. And I also want to note that these alkanes, they are one of also the main compounds that are on highly demand. So to obtain them, we can carry out fractional distillation of crude oil. We can obtain them from natural gas, which is found as a layer on the crude oil deposit, or we can obtain them from biogas. That is the industrial source of alkanes. Also, we can obtain alkanes from laboratory preparation. We can prepare them in the laboratory. we can prepare alkanes in the laboratory. And now we want to talk, how do we prepare alkanes from the laboratory? We're in the laboratory now at school level. How can we prepare alkanes? So before now we talk about preparing alkanes, let's first see the naming of the alkanes. Because remember, we said that all alkanes, they have a homologous series which follows this formula, CN, H2N plus 2. And this is a very important formula because it will enable you to write any structural formula of any alkane. So the formula is CN, H2N plus 2, and that's the general formula of the homologous series of alkanes. So alkanes, they appear according to their numbers. We have different numbers of carbon. So you will find that if we have a number of carbons here, and then you shall have the name, shall just try to reduce a few of them. So if we have one carbon, we have a hydrocarbon lying under the homologous series of alkane with one carbon. So what will be the formula? What will be the formula of that? What will be the formula of that hydrocarbon? So if it has one number of carbon, then it will be C, because N is 1, so it will be C1. H, 2 times 1, which is, that one will give us 2, then plus 2. So in overall, it will be C, H4. So number of carbons being 1, the formula will be C, H4, giving us the name methane. So methane will always be the first group of alkanes. Now, in naming alkanes, or any hydrocarbons, which we talked about here, alkanes, alkenes, and alkynes, hydrocarbons are given two names. The first part is the parent name, and the second part is the suffix name, which comes from the name of the parent, or the parent homologous series. So for example, the first member of the alkane group here with one carbon is methane. Now, methane is the parent name because it has one carbon. So because it has one carbon, it will be called meth. Meth, because the name is methane, we said that the first part, which is meth, is the parent name. So if it has one carbon, it will be meth. Meth will be our parent name. And now, N, it comes from the homologous series, which is alkanes. So we take the AN and give it to the parent name. We add to the parent name and hence call it methane. So methane will become our name of the first member of alkane. And remember, the first name is the parent name, and then the second part is the suffix name from the homologous series. Okay, let's try to find out the second member of the group of alkanes. So the second member will have two carbons. The number of carbons here is 2, so it will be C2, hydrogens, 2N plus 2. So it will be 2 times 2, which is 4, then add 2, giving us 6. So the second member will have 2 carbons and then 6 hydrogen. So it will be C2H6, following the formula of CN H2N plus 2. Good. So how will we call this? Because it has 2 carbon atoms, then we shall call it eth. Eth will be our parent name. Eth will be our parent name. Now our suffix name, which is ANE, when we add it here, now it will be ethane. So ethane will become our name of the second member of the group alkanes. Remember, the first name is the parent name, and it depends on the number of carbon atoms. Good. So if we have 3 carbon atoms, the formula will be C3, then H8, and we shall call that propane. And then when we have 4, it will be C4, H10, and we shall call that butane. If we have 5, it will be C5, because we have number of carbons is 5, so it will be 5 carbons, and then hydrogen will be 2 times the number of N, which is 5, giving us 10, then plus 2, which gives us 12. So we call that pentane. Good. So that's how we name the alkanes. That's the procedure in which we use, or the criteria we use to name the alkanes. Good. So let's go back to the laboratory preparation. The method used for preparing all those compounds that belong to the same homologous series is 1. In fact, that's also another property of homologous series. You realize that all members of the same homologous series can be prepared using one unique method, or one specific method. So let's talk about the laboratory preparation of alkanes, and we shall just pick an example. Good. So good. So alkanes in the laboratory are simply prepared by reacting sodium alkanoate, that is sodium alkanoate and soda lime. We prepare alkanes by reacting sodium alkanoate and soda lime. Sodium alkanoate it's simply an organic salt which is obtained by reacting a metal, sodium metal or sodium hydroxide with an alkanoic acid. For instance, if we can react sodium with ethanoic acid, we shall come up with sodium ethanoate with soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide. Now, in this soda lime, it is sodium hydroxide that reacts with the alkanoate. Good. So, when we react sodium alkanoate with soda lime, the sodium alkanoate reacts with sodium hydroxide and it gives us the respective alkane. Let's try an example. If we have sodium ethanoate, we have sodium ethanoate and we are reacting it with soda lime, we shall get methane plus sodium carbonate. So I want to explain to you how this one comes to happen here, exactly what takes place here. So for you to identify or for you to realize what happens here, to understand exactly what happens here, you need to be able to write the chemical equation of this reaction. Because writing chemical equation is one of the key elements in chemistry and it will save you a great deal. So let's begin with sodium ethanoate. How do you write sodium ethanoate? Now, like I said, sodium ethanoate is obtained by reacting, it's just an organic salt, so it's obtained by reacting sodium or sodium hydroxide with an alkanoic acid. And for this case, if we have sodium ethanoate, it means we reacted an ethanoic acid with sodium or sodium hydroxide. So the formula will be, because it is from ethanoic acid, so we shall have carbon, and then hydrogen here shall have 3, and then carbon, sodium. So this is the formula of sodium ethanoate. That's the formula of sodium ethanoate. So this one is the alkanoate. This one is the alkanoate, which we shall study it under the organic chemistry 2, how this one is formed. In organic chemistry 2, we shall be studying how sodium ethanoate is formed, because collectively it can be set under a flowchart, and you need to be able to write the equation how they come up with this sodium alkanoate. So when you react this sodium alkanoate with soda lime, and I said in soda lime we are specifically reacting with sodium hydroxide, now this is what happens. We have here carbon. In this equation, you have this one carbon. So this one carbon will come here, and then H3. So this is the first part. And then the hydrogen from the hydroxide, in the sodium hydroxide, that hydrogen atom will also combine here, forming 4. Because this is CH3, and we have one hydrogen here, so we are adding one hydrogen here. So this hydrogen is lost from sodium hydroxide, or this hydrogen, it displaces this carboxylic group, and then it attaches itself here, forming CH3. So instead of CH3, now it will become CH4, because this CH4 has combined with this hydrogen now to form CH4. That's what we call methane, because our methane, the formula of methane was here, CH4. So it forms methane, and then we are left with sodium here. And then we have 2 moles of sodium here. We have one sodium here and another one sodium here, making them sodiums. And then we have carbon, and then 3 oxygen atom, which gives us a carbonate. So in general, when alkanoate, sodium, that is a sodium alkanoate, it reacts with sodium hydroxide from the soda lime. It gives us methane gas and sodium carbonate. And I have just explained how this reaction takes place, and I'll just repeat. This, the first part of the alkanoate part here, the CH3, will join with the hydrogen from the hydroxide to form the methane, which is CH4. And now we shall be left with the sodium oxide here. So we have 2 atoms of sodium, which will join to form sodium. And then we have 1 carbon left and 3 oxygen atoms left, which will now join to form sodium carbonate. Good. So I'll just delete this. I hope you are together. Good. So the diagram will look like this. So here, in our volumetric flask here, we shall have sodium ethanoate, which its formula is there. Shall have sodium ethanoate here, reacting with sodium hydroxide to give us methane and sodium carbonate. So we are reacting sodium ethanoate with sodium hydroxide. It will give us methane gas. Methane gas. So let's look at the properties of the alkanes before we write another formula for elaboration. Now, on the physical properties, because every element has its own physical properties and chemical properties. So about the properties of alkanes, we shall begin with the physical properties. Now, on the physical properties, alkanes are slightly insoluble in water, and that's why you can see we have collected them using over the water method. This is called over the water method among the main 3 methods of gas collection. So because of its property, which is slightly insoluble in water, it makes us possible to collect it under the method shown, which is over water method. The gas is also colorless and odorless. So those are some of the physical properties of this gas alkane, the alkanes, which comprises of the methane gas. So like we said, they belong to the same homologous series, which is alkane, and these physical properties of methane, it represents all other physical properties of any compound present in that group of alkanes, or the same homologous series or homologous group. Good. So one of the physical properties is that it is slightly soluble in water, and if a gas is slightly soluble in water, then it means we can collect it using the over water method. And then the second one, we have just said that it is odorless and then it is colorless. So inside this reaction chamber, you can be given, this one is sodium ethanoate. You can go in examination situation and you find that in this one, you have been given sodium propanoate and soda lime. Now just remember that when we react sodium ethanoate, it gives us methane. So when we react sodium propanoate, let's see what it gives us. So like I said, sodium propanoate is just an organic salt, and it's obtained by reacting propanoic acid with sodium. So sodium propanoate, here's sodium propanoate. So we have sodium propanoate here, reacting with soda lime here, which is sodium hydroxide. We want to see which gas shall we obtain here in our collection there. So, like I said, we have 2 carbon atoms here. So we have 2 carbons. Good. And then we have hydrogen, have 7 hydrogen atoms here. So these hydrogens will come here, because there are 7 hydrogen atoms and we have 1 hydrogen being contributed by sodium hydroxide. So this hydrogen will combine with these 7 hydrogens to form 8 hydrogens. And this gas, we call it ethane gas because it has the formula CnH2n plus 1. Hence the name ethane, that's plus 2. Hence the name ethane, that's the homologous series name. That's the parent name here. So ethane is given due to the number of carbons, and N is the suffix name which give it depending on the homologous group in which it lies. And because it lies on alkanes, so its suffix name will be AN, meaning that it comes from alkanes. And eth, as we said, it's because it has 2 carbon atoms. Good. So also, we shall also form sodium carbonate as a additional product from the reaction. So from the reaction taking place, that's what we form. The sodium, the equation is automatically balanced because we have 2 sodium atoms on this side, and on the reactant side we have 2 sodium atoms, and also we have 3 oxygen atoms on the reactant side equal to 3 oxygen atoms on the product side. So if you react sodium propanoate, you will get ethane gas. So if you react sodium butanoate or sodium butanoate, you will obtain propane gas. That's what happens. So you should train yourself on writing the equations so that in case of exam situation, you don't lose the marks on the equation and also identifying the gas. And you see now for the diagrammatic equations like this, it's very important if you are able to write the equation. It's very important if you are ready to, or if you know to write the equation, because the equation will guide you to know the product that is being produced here. Because in exam, they can draw the diagram for you in this case, and then you have a gas here. We have propane gas here. And now they are asking you to identify one of the reagent here, and you have been given soda lime. So one of the reagent that you have been given here is soda lime, and now they'll be asking you to give another element or another another compound that can be reacted together with soda lime to obtain propane. So you should be able to know that it is sodium butanoate. And also, you'll also be asked to write the equation for the reaction, which you should also be ready and prepare yourself to know how to write a well-balanced chemical equations on the same. Also, they'll ask you simple questions like, why do we collect the gas using the above method? So you should know that for us to collect a gas using overwater method, it's because the gas is slightly soluble in water. Okay, so that was just on the physical part of alkanes. And now let's talk about the chemical properties of these alkanes. So, like we shall see in the preceding subtopics of the alkenes and alkynes, they undergo several reactions, chemical reactions, which alkanes don't. And remember, we said that alkanes are covalently bonded to each other with 1 carbon atom. And for a carbon atom to be stable, it must have 4. It must have the 4 atoms, or 4 bonds covalently filled, all of them. So that's why, because this carbon is bonded to the other one with only 1 single bond, or only single bond, we say that it is saturated. It cannot be broken into any simpler bonds to accommodate any monovalent or even divalent atom. So, meaning, on chemical reaction, we shall see that these alkanes, they can react with halogens, and that type of reaction we shall call it a substitution reaction, because for them to react with any other compound, it means, or any other atom or element, it means that that element, if it's, let's say if it's chlorine atom, then that chlorine, for it to react with this, it will have to displace some hydrogen ions from its position so that it fixes itself there. That's why you say that it is a substitution reactions. Let's just give an example. So under chemical properties, we have said that alkanes can undergo several chemical properties, and the first one is alkanes can react with halogens. And talk about halogens, we talk about bromine, iodine, and chlorine. So suppose we have a alkane here. Let's say we have a alkane number 3, and that is, it has 3 carbons. We have alkane number 3, and that is pentane, that is propane. So propane is reacting with chlorine. So because, let's draw the open structural formula. This one have 3 carbons. So all carbons are bonded with hydrogen. for stability, like this. And now, you see, because they have a single bond, we cannot break the bond further to accommodate this divalent atom here. So in order for it to react, it has to displace some hydrogen from this parent compound. So because we have 2 atoms of chlorine here, it means we shall displace 2 atoms of hydrogen. So we shall come, or shall remain with CH3, CH2, then C, we have H, and then this chlorine will attach themselves on this position left by hydrogen to form 2 chlorine atoms. And then because we have lost 2 hydrogen, these 2 hydrogen atoms will combine to form a hydrogen gas. So this is what will be formed. So what is important here is to know how to name the compound formed. That's why we're going to talk about naming of alkanes, knowing how to name this compound formed here. So from the open structural formula, this one, its open structural formula, we have a carbon bonded to 3 hydrogen, then carbon and 2 hydrogens here. We have carbon and hydrogen, then have chlorine and another chlorine. Good. Now, this chlorine, they have displaced 2 hydrogen atoms and detached themselves there. And the hydrogen atoms which have been displaced combine to form hydrogen gas. Because they have been substituted, the position which was initially occupied by hydrogen, that's the type of reaction we call it substitution reaction. So that's substitution reaction, and the specific type of substitution reaction which have taken place here is called chlorination. Now, for substitution reaction to take place with halogens, to form halogen alkanes, there must be 2 conditions. One, there must be UV light. UV light, that's one of the conditions. So for chlorine, which is a halogen, or even iodine or even bromine, to react with an alkane to form a compound, there must be presence of UV light. The reaction cannot take place in the darkness. So you will see that in examination situation, you will be given a question like this. In examination, you will be given a question. Let's say that is methane, and it is reacting with chlorine. And the condition here is unknown. And you will also be asked to give the name of the products. So remember, the reaction between alkanes and halogens is a substitution reaction and cannot take place in darkness. There must be UV light. There must be presence of ultraviolet light for the reaction to take place. And when they react, the hydrogen, because we have 2 atoms of chlorine here, so they will be displaced 2 atoms of hydrogen and occupy the space. So they will be substituted in that space left by the hydrogen atoms. Initially, we have 4 hydrogen atoms bonded to 1 carbon, and then we are reacting with the chlorine. And because we said that these alkanes are saturated, they cannot be broken further to accommodate any monatomic or divalent atom. So for this chlorine to occupy this space here, it has to displace this hydrogen, forming that and hydrogen gas. So how do you name this? How do you name this? So to name a compound, first we must first identify the number of carbons it has. For this case, this one has 1 carbon, so its parent name is still just meth because it has 1 carbon. Because it has 1 carbon, it's just methane. But then we also have this halogen. We have chlorine and chlorine, which are 2 atoms of chlorine, and they are all attached to the first carbon, that 1 carbon. So because it's the 1 carbon here, we shall call this, because they are 2 chlorine molecules, so we shall call them dichloromethane. So methane comes from the parent name, which is given by the number of carbon atoms that compound contains, and because it has 1 carbon, so it is methane. But because it's attached to 2 chlorine atoms, then it will be dichloro, because you have 2 chlorine atoms attached to the same carbon, so it will be 2 dichloromethane. Good. Also, let's see an equation, what happens when an alkane reacts with bromine. So for this case, we shall have an alkane. For instance, let's say we have butane. We have butane, and it's reacting with 2 moles of bromine. That's 2 moles of bromine. and bromine is diatomic, so of course it's bromine 2. So the open structural formula of this will look like this. We have 10 hydrogen atoms attached to 4 carbon atoms. And because we are adding, because see here, bromine is diatomic, so it means this bromine has 2 bromine atoms. But then the mole, you have 2 moles here, that they exist as 2 moles. That means we in total you have 4 bromine atoms. So for these 4 bromine atoms, for these 4 bromine atoms to react with this butane, they'll have to displace 4 hydrogen atoms, and these 4 hydrogen atoms will be substituted with bromine, forming this. Now, this one has been substituted by chlorine, and then this one has also been substituted by chlorine. And the 4 hydrogen atoms that have been displaced will come here and also form 2 moles of hydrogen gas. So how do we name this? So to name this, we begin with the side in which the halide is attached, and the halide is attached on this side. So we just identify the longest carbon chain here. So we have how many carbon C atoms? We have 1, 2, 3, 4. So the parent name will be butane because we have 4 carbon atoms. So the parent name will be butane. And then we have 3 chlorine atoms attached to the first carbon. So on the first carbon, we have 3 chlorine atoms attached to the first carbon. Yeah. And then on the second one, we only have 1 chlorine atoms. So this one, it simply it represents or indicates the position in which the halide is attached to the carbons. So 1 simply indicates that we have a chlorine attached to the carbon number 1, and then also another to the carbon number 1 and another to the carbon number 1. And then 2 indicates that we also have another halide attached to the carbon number 2. Now in total we shall have how many chlorines? We shall have 4 chlorines. And to represent that number of chlorines, we use the words like di, tetra, or tri. So because here we have 4, so it means that we have 1, 1, 2, tetra. Tetra means 4, tetrachlorobutane, because butane is the parent name. So butane is the parent name. Good. So that's one of the chemical properties of alkanes, is that they also undergo a substitutional reaction by reacting with other halides to form halogen alkanes. Another property of alkanes is that they burn in air to produce carbon 4. Alkanes burn in air to produce carbon 4 oxide and water. So hydrocarbons, all hydrocarbons, they burn in air to produce oxygen and water, carbon 4 oxide and water. But for this specific group of hydrocarbons, the alkanes, remember we said that they are saturated. So I want to remember this for the sake of practical. When we burn alkanes in air, they burn with a blue non-sooty flame because they are saturated. So they burn with blue non-sooty flame. So that's one of the properties that is visible. When you burn the alkanes in air, you'll see that they'll burn with a blue non-sooty flame. For example, suppose we are burning here a butane. We are burning butane in air. So it's reacting in oxygen. So it will form carbon 4 oxide and water. So that one will happen if the quantity of oxygen that we are burning with is in excess. There's excess oxygen. But what happens when we burn it in limited oxygen? If we have limited oxygen, remember, because there are just still alkanes, because there are still alkanes, they just burn with a blue non-sooty flame. But now in this case, they will produce carbon 2 oxide and water. So that's what happens when alkanes burn in air. You need to remember that they burn with a blue non-sooty flame. And then the last thing on alkanes is their uses. You will also be asked about the uses of alkanes. Now, remember, examples of alkanes, said you have methane, and methane is widely used at homes for cooking. So that's one of the applications of alkanes that are used in homes for cooking. We also have these same alkanes. We have methane. Methane is used in homes for cooking. It's used as a fuel in cooking at homes. It's used in cooking. Good. That one is used in cooking. Also, these alkanes, they are sources of hydrogen gas. When they're broken down during the cracking process, they produce hydrogen gas, which is used in hydrogenation. So, apart from knowing the method of preparation of alkanes and their physical and chemical properties, also remember to look at their uses, because that's also examinable. So that will mark the end of today's lesson, and let's meet for the next class. Yours, it was Mr. Byron. So have a nice day.